My name is Jeremy Mikola, and I'm going to be sharing a little bit of it today about things from the PHP internal side, and kind of walk through the things behind the PHP source code. A lot from the C perspective, extensions, how PHP works inside. I'm not sure why Sensio picked this for this conference, but happy to talk about it. So as soon as I figure out how to do page down here. No, it's not working. One second. Okay. So a little bit about myself. I work for MongoDB. They sponsor most of my clothing, backpacks and such. I've been working with Symfony and mugs, or a whole kitchen. I've been working with Symfony not for the last 5 years while I've been working at Mongo, but beforehand, and that goes back, I keep getting that number, 9 years, kept getting bumped up every year. And I have been to a bunch of Symfony events in the past, so definitely happy to be here today. Definitely still have a good connection to the framework. And then on the side, I'm working still with Doctrine, and that more so kind of everything shifted over to that because it's more database related, so I help out on the Doctrine ODM. And I also, part-time, organize a sausage conference known as WorstCon. From other Symfony conferences, you might remember me as the Jeopardy guy. That's me. I was a little more excited then. It's pretty early right now. Also the proud father of this doggo. His name is Milo. He's a cockapoo. So different topics I want to cover today. To clarify that what I do at MongoDB is still doing PHP stuff. And basically brought on as a PHP developer with experience working in Doctrine and Symfony and things, and knowing nothing about C. And then while being there, being tasked to learn how to write C and take over maintainership of the PHP extension. And so that's the driver. And then today we've rewritten it over the last couple of years that I've been there. The driver consists of a low-level C library that does the socket communication, all that stuff. And then a higher level PHP library, so I get to use namespaces and good design patterns again, which you really don't get to do when you're writing PHP extensions. So kind of the best of both worlds and a good learning experience. The topics I want to go through today, kind of introduce, I don't know everyone's background here. I'm not going to waste your time with like raising hands for each of these. But I want to start by talking about what is the PHP lifecycle, so how the processes, how requests are served. I think most of us have an understanding of request responses as it pertains to web frameworks, but what does that look like inside when PHP is running its request? Clarify the different types of PHP extensions, because there's at least 2 types if you're not familiar with them. Look a little bit about the internal data structures, and I'm not going to spend too much time on that because it'd be looking at a lot of C macros and structs and not very exciting stuff. But more importantly, the goal here is to leave you with some action of like how you can research the stuff on your own and how to make sense of the things behind your PHP source code. So we're going to look at some of the tools available to navigate PHP source code instead of just going to the Git repository and saying which of this mess of directories am I looking for if I want to see how a certain function works, how do I find that? We'll look at how PHP files are executed and what insights you have available into that. And then talk a little bit about opcode caching. Opcodes are basically the machine code, quote unquote, for PHP. And then look at how PHP interacts with C, and then I'll play into some debugging stuff. And then something I do regularly with the Mongo driver is debugging crashes, whether it's our fault or someone else's fault. So I'll share some knowledge of that and some best practice for using GDB for that. So start off with this nice calming slide of an elephant with some baby ducks. So everything starts basically in both PHP and any C program with this little int main function. There is no, it's not like a PHP file where you just have this global scope. This is basically the entry point where when the operating system runs your program, it's looking for this. And that carries over if it's written in C, if Java is running, there's something equivalent to this that enters. And so the really basic do nothing below hello world is basically returning 0 success. And I have a little asterisk there because as this applies to PHP, if you're running, the one edge case is if you're running PHP in Apache, as like a module. In that case, PHP doesn't have a main function because it's not being invoked directly. It's kind of registering itself into Apache. But rest assured, this is how Apache starts, so I'm not really lying to you. And just some examples here. So this is the, this is the PHP CLI. This is the old PHP CGI interface, and then this is the fast FPM interface. So they all have this function here. And these are all referred to as SAPIs. You'll find them in that directory. There's a few of them. PHP 7, they removed a lot. They used to have some for like the old AOL web server that someone was still maintaining through PHP 5.6. Those are gone now. They've kind of condensed the list. But server APIs, and hopefully this isn't the first time you've heard about this, usually abbreviated SAPIs. The most common old one that I think a lot of people have used, especially if you use bundled like MAMPs or LAMP products, is the Apache module. And then it's PHP registering itself in Apache. So when things crash, it takes down the entire web server, which is a fantastic feature. There's the command line interface, which we probably all use every day, at least through Composer. The common gateway interface is the old way of like the CGI bin with Perl scripts from 20 years ago, if anyone remembers that. But more recently, that's basically how FPM works. It's still that same process of the request comes in with its environment variables, the PHP process decides to create some output and sends it back out via a socket. So fast CGI is really the same interface, but now it has process managers and we have worker processes and everything. Whereas 20 years ago, when you hit something in CGI bin, it would basically run a process on the machine, collect the output, and send it back to the user. So there's a bunch of these things available. And inside PHP source, we also have a bunch of extensions. So the two main groups, you have stuff that controls the PHP language. You have the SAPIs, which are basically integrations for the PHP runtime into your web server or however you're going to be connecting PHP with your users and the clients. Then you have all the extensions that exist, and you have a lot of them that are built in. And these are basically maintained in PHP source. And then we also have things that are in PECL that live in other repositories. So a lot of things like the Redis driver, the Mongo driver, these are separate, and we just publish them in PECL, which is basically packages for PHP extensions. And then you have the ones that are maintained. So with these, you're at least guaranteed that if someone updates PHP, that these are still compiling and still work just fine. But these can still be, sometimes these are statically compiled in, and then sometimes these are dynamically loaded. And so if you're not familiar with that, with the statically compiled, every time you're running a PHP process, you always have access to these extensions. So something like the datetime extension or the SPL stuff. Like you would never have to load those in your INI files. Whereas other things like maybe like Xdebug, which actually isn't here, but sometimes like on Red Hat, the JSON extension is actually separate and you have to load that. So depending on your PHP deployment, these could be dynamically or loaded in there. And there's quite a, forgot I had a transition here, quite a lot of them. And so the two types of extensions, I just want to briefly overview. So the things we commonly refer to extensions are modules. These are the ones that we use. They provide classes to us. Things like maybe operator overloading, OpenSSL extension. So things that, a lot of the things we find documented on php.net that we use every day are modules. And the main goal here is they integrate something with a C library. So in the case of datetime, Derek Rethens maintains that. He has a C library that does all the timelib calculations, which bless his heart for maintaining that. It's a really disgusting thing that you wouldn't want to maintain in PHP code. And so that integration, same thing like APCU, is like the userland cache. Our Mongo driver integrates with a C library to do that. OpenSSL, of course, and that exposes things so you can do like certificate verification in PHP code. And then we have the Zend extension side, and those are going to give us a lot more hooks for changing PHP's behavior, not so much exposing functions and stuff to the users. So this is commonly going to be used for debuggers and profilers. So like Blackfire product is a Zend extension because it does profiling. It needs access to extra, the inner workings of PHP as it's loading opcodes and doing memory analysis. And a lot of these are going to be dual purpose extensions like OpCache or Xdebug, because they do have userland APIs. And so the single OpCache extension may have a Zend extension for all the hooks and the optimization stuff on the internals. And then the kind of user-facing side that we would interact with as a PHP developer is going to be published as a module and a regular extension. Even though that's one giant ball of C code, it could act as both and register itself as both types of extensions. And looks like we just missed something here. Okay. And so just an overview of what some of these hooks are, and I'm going to get into these. But that little cloud in the middle is basically your entire Symfony application. Your full-time job runs in that little cloud, and then around you is this big spectrum of all these other things that we don't have to think about. But if we look kind of like just running down the chart, as PHP starts up, it's going to load all of its modules. It's going to load the extensions. The Zend extensions also have to start, and they're going to actually start after, so that they have a chance to be fully aware of all the other code that's running. This is definitely relevant for debugging and profiling. And then on the way out, it's kind of just like a stack goes in, and then we come back out and we deregister ourselves the same way. And so I want to talk about a little bit about the scope of how this applies to serving requests and what happens on every request. So with extensions, and this applies to PHP core because a lot of even like there's a main extension in PHP for a lot of the basic functions we use. So everything really boils down to an extension API. There's a module scope, and this is where the extension initializes itself. It's going to set up some state that it needs over the core, register INI entries, class entries, global functions that it provides, maybe initialize third-party libraries. And on the way out, we're going to be responsible, not leak memory, unregister ourselves. Anything that if we allocated memory, we want to make sure we clean that up as well. And then inside the request scope, and this is something that, so the arrow kind of loops back of itself. If you have a PHP process, so a CLI process would basically do one request and end. But something like FPM, where you have a worker that the process stays open, it keeps serving HTTP requests. So we need a hook for the request scope, similar to if you look at the dependency injection container in Symfony, you have a request scope. If that still exists, I last used it in version 2. So sorry if that's inaccurate. But on every request, there might be certain things that we need to initialize in the extension or behind the scenes to service that one HTTP request that comes in. And then this is going to be, there might be request-bound memory, so there might be resources that we just need, and we can, the PHP internals provides us a memory management system so that we can allocate things, and if we forget to free it, it'll complain about it, but it won't let it actually leak and disrupt the rest of our operating system in the process. So that's referred to as a Zend memory manager. So and there's two types of memory, like outside in the module, we're maybe permanently allocating memory, and then inside here, we're going to allocate memory even inside the extension, just like if you have allocating PHP variables. So you create your variables, your objects in PHP, you're guaranteed that when the request is over, it's a share nothing architecture, all your memory comes back to you for the next request. So it's kind of hard from using pure PHP to leak memory between requests. You can still do it, but it's quite difficult. And so Zend Memory Manager definitely helps there. And now there's a difference here in how we run PHP, and this is probably more appropriate for things like the Apache module versus FPM or the CLI environment. So traditionally we have a process model, and then this is one PHP process, and it serves one request at a time. There's no threads or anything like that. It's a kind of a single purpose. And because we have, ideally you have more than one user on your application, we probably have a queue of these and workers handling a bunch of requests concurrently. But these are easy to manage. If one breaks, it doesn't affect the others. And then you have the ridiculous, and this is, I guess, purposely drawn to be disorderly, the threaded model inside an Apache web server if you're using PHP modules. And so you have one process juggling a whole bunch of requests concurrently. And they're really all inside this outer box. They're all kind of sharing the same memory. So PHP provides us internally some resources to deal with threading so that each request doesn't step on each other request so's. Because it does become trivially easy to disrupt another request if you were to write to the wrong portion of memory. And then lastly, we have this global scope, and these are also the hooks that get initialized. And this is for kind of initializing, similar to what you would use globals for in PHP. So some extensions would need some global state. So inside like the MongoDB driver, we keep a global cache of the connections and sockets so that we can reuse those from request to request without having to incur setting up new connections every time an HTTP request comes in. And then this differs a little bit for the process and the thread model. Basically the main takeaway is with the thread model, every thread we also have to make sure that it initializes its globals and cleans it up. Because when we create a thread, we're basically inheriting some state from the parent process. So the global scope adds a little bit of complexity to that, but generally you'll use these things for caching. And this, as I was writing these slides, I came like a little epiphany while I was taking a shower. Remembered the PHP Process Manager, and this is a React PHP based application that specifically I think was designed with Symfony, Laravel, and Zend framework in mind. And basically it is a PHP process that creates a bunch of workers, coordinates them via React PHP, they each listen to an HTTP request. So each one of these is a PHP CLI process, and they're serving the HTTP request. So this is basically, it'll bootstrap your application, like your Symfony dependency injection container, everything, and use it to handle multiple HTTP requests between, in the lifetime of the PHP process. And so this is basically running the same thing that PHP itself internally just does, but now inside PHP. Now, why someone came up with this idea, it definitely has performance improvements. But if you think of the challenges that it has, like one of their biggest issues is memory leaks, particularly because we no longer rely on this share nothing between request architecture. So PHP internals are not, the requests are not being deinitialized. This all happens inside one CLI request. So kind of all the problems that PHP internally solves, by them creating this project, they have reintroduced all the same issues for them to try and overcome. So with this, it is difficult to worry about resetting the state and leaking memory in between. And so it's really immediately thought of inception and going deeper. So I'd be remiss not to discuss Zvals. Hopefully everyone's heard this term. I just want to spend a few slides discussing it. This is basically the data structure inside PHP that keeps track of every variable, every value inside PHP is represented by a Zval. And so these are purposely tiny because we create maybe a Symfony application create millions of these things. Certainly more so if you're using something like Doctrine. And so in PHP 7, these are really optimized to be as small as possible. And it's basically a small structure. So they give us like a class with public properties in C. And they contain 3 fields, and they're union fields, which are basically multi-purpose fields. So union, if we have one structure that's a union in C, that means the same segment of memory, so the value being 8 bytes, this can masquerade as different possible values depending. It could be a pointer to a certain other data structure. It could be a 8-byte integer. It could be a Boolean value. As long as it occupies the same amount of memory, we can interact with it different ways. So kind of like casting it to different types. Think of it that way. And then for the Zvals, integers and double values are small enough that we can embed them entirely. They're only 8 bytes long. Things like a PHP string, a class, and object, there's no way these are going to fit in 8 bytes. So those will have pointers to actual data structures elsewhere, and as well as like arrays and objects. Additionally, in this, we need some indication of like what type we're dealing with. Since the value is a union field, it could be any number of things. We need some flag to tell us, well, how should we interact with the value? So that's going to be the type info. I'll talk a little bit about that. And those are going to be some flags that tell us properties about it. So it might be an array that is immutable, which maybe in that sense comes from a PHP, like a array literal in PHP source. So different properties so that the PHP interpreter knows how do we interact with the Z value. Do we need to free it when we copy it? Is it a reference counted? Things like that. And then lastly, in C, the wonders of memory allocation, things are kind of allocated in 8-byte segments. So the Zval really only needs 12 bytes, but we'd have 4 bytes left over. So internally, we use this extra 4 bytes for all sorts of other multi-purpose flags as well. And I'm not going to talk about that at all. But those are things like for each iteration. There's 4 extra bytes. We could use them. It's basically use it or lose it. So it's kind of a freebie here. And then in PHP 7, and hopefully everyone has moved to this so far or is contemplating it, there were 2 major improvements to Zvals. And this, again, because every PHP script creates so many of these, this paid off in dividends. So one, they're no longer heap allocated, which there's 2 ways of allocating memory in C. And with heap allocation, we basically have to, every time we need a value, go like purposely allocate it versus like declaring it within a function would be stack allocated. So heap allocation is much slower. We have to go to the memory manager and request a new bit of memory. And then instead of it having be accessible to us, we might be pointing to memory somewhere else, not near our process. So these, by making them smaller, we can now directly embed them in things. This is definitely helped with things like PHP arrays, which are represented as hash tables internally. Because now instead of having an extra jump where we have this pointer to Zval, now I have to go look in another place of memory and then maybe keep jumping if I want to find the string data and stuff like this. That's one less jump. And think about how many times we interact with arrays or object properties. This is saving us from traversing memory thousands, millions of times every request. Additionally, a big change was that in PHP 5, Zvals themselves were ref counted. And this kind of it maybe made sense because Zvals were they represent arrays, they represent objects and strings, but something like integers and other values that can be embedded, this was really quite a bit of overhead. So in PHP 7, the zvals themselves don't do any of the ref counting, and that's all been shifted onto the actual types that need the ref counting, which as an extension developer makes the job of interacting with zvals a lot easier, and then it also removes a lot of that extra overhead. And it allows other optimizations to take place, such as like array literals and immutable strings, things like that. So ultimately, much less indirection, pointer traversal. These are just generally faster to work with. And then in the other types, we'll briefly go over with strings in PHP 5, we basically had a string in C is basically a pointer to a bunch of bytes in memory. There's no indication of how long it is. We have to track that separately. So it's really just a character pointer. In PHP, and that was really a pain in the ass to work with. In PHP 7, we have a actual string type, which one is reference counted, so it keeps track of how many zvals are referring to it. It keeps track of the length and the character array there. Another important improvement is that the string data itself is embedded into this structure. So that's, again, removing an extra jump that we have to do. And these kind of, all the improvements played into themselves. So the same benefits that we see in the string representation with objects. If you have declared properties in your objects, those are also embedded inside the object struct. And then if you're dynamically creating properties, like if you just randomly create a new member and assign a variable to it, those are handled dynamically in a hash table. But the properties that we know about when we compile a PHP class can be built in and kept in sequential memory, which makes things much more performant. And another big improvement for hash tables, if you work with true arrays where the keys start at 0 and they go sequentially, no gaps, there's definitely optimizations for that to make that a lot easier than in PHP 5. Those are referred to as packed arrays. So just some of the type attributes, and this was in one of those 4-byte fields. So things that are ref counted. So simple types, those are integers, booleans, null values. Basically all the other types there, strings, arrays, objects, resources, which are still used for some things. And a reference itself, if you create a reference to another PHP value, those are all things that we do reference counting on. If anyone's familiar how garbage collection works in PHP, with reference counting, when we have a variable and we know that there's no more references to it, say you declare x equals 5 and you unset x, there's no longer anything referring to it, so PHP can immediately free the memory. Things that are collectible are arrays or objects. So with a string, we're guaranteed that the string can't refer to itself. It's just having some bytes and data. But an array, you can have an array refer to itself. You could have an object have a reference to itself. This frequently happens if you're using like Doctrine ORM, where you have relationships. And for this, we can't use reference counting because ultimately there might be two objects that refer to each other and they are the only reference to each other. So PHP has a cyclic garbage collection that basically has to go out and know which things are collectible and kind of look for that purpose. This is something that came up with an old Composer improvement, which was disable that cyclic garbage collector while you're running Composer because it's not going to do any good while it's computing all these dependencies, and we'll just let the process free the memory later. Things that are copyable are basically, we think of like when we pass objects, call it pass by reference semantics, not really, but we're arrays or strings and we move them around. Every time we make a copy of them, the data itself gets copied. And then a mutable flag is really just an immutable array was a new type that was introduced in PHP 7. And this is basically an array literal has a special optimization. So if array literal appears in your source code, maybe you assign it to a constant or something, it doesn't need the same overhead as an array. It's not going to have a reference to itself because it's a literal. You can't, every component in that is literal. So that's a special optimization there. Okay, so knowing about a little bit about zvals and SAPI's extensions, where they live, comes time you want to dive into the source code and see where these things are defined, not just take my word for it that I'm describing the things correctly. Certainly not a full expert in all of this. There's a tool available referred to as LXR is a traditional name. It was originally called the Linux Cross-Referencer, originally a Perl app. And nowadays, this actually runs a Java tool that does a similar thing. But it's basically a source code browser. And this is maintained by somebody. Room 11 is the Stack Overflow PHP channel. If you're not familiar with that, it's just a community chat room. So the interface kind of looks like this. So you come here, there's a bunch of projects displayed. Somewhere down there is all the PHP branches for PHP 7.0, 7.1, 7.3, etc. And so let's say, just for example, I want to look at, well, how is inArray implemented? It's a pretty basic function. We basically give it a value, we give it an array, it returns true or false if it finds the value. So I'm just curious, this is concise enough where I feel like I could digest what the implementation might be. I go to PHP source in GitHub, I have no idea where this is defined. So I go in here and I could search, I could just search for inArray. I know from experience that like the functions that we have in userland are declared with this macro. So they're not exactly C functions, they need to be registered so that we use a PHP function macro and then the name of the function. This will end up accessible to us in PHP. So if I search for this down at the bottom, I can find it. The declaration is in some header file, and then array.c presumably is the implementation. So headers are just the declarations. The .c files is where the business is. That's what we want to look at. So I'm going to click on that. It's going to take me, immediately jump into that file at the appropriate line. We have this proto at the top, and this is kind of I think a doc block for the internals. So that kind of gives us what the PHP API for this is nothing what the C API looks like, because as a C function, this takes all sorts of extra things, and it's also all hidden behind that PHP function macro. But that kind of tells us that, yes, it takes the needle, the haystack, hopefully we have the order right there, and then the Boolean flag for whether it's strict or not. This function doesn't actually do anything, but just by looking at this slide, we could say, well, array search is actually also using the same internal function. So PHP search array is some common function that they do. Now, while I'm here, the benefit of LXR is that everything that you see, all these identifiers, macros, are clickable. So you can resolve them, they'll take you right to their definition, which would be a lot harder to do if you were just browsing this with like Sublime Text, or certainly PHP Storm is not going to help with any of this. So I'm just curious what internal function pass-through is. It's basically just a definition of two other arguments so that we don't have to keep typing these things. And the same way, like if you wanted to find out what PHP method was, or how that's defined, click there and it would show you, and it's basically some structure around defining a C function and registering it. Okay, but let's jump back to the PHP function for inArray. And I want to see what PHP search array actually does. So I'm going to click on that identifier. That's going to take me into the C file where that is defined. And here, now this looks like readable C code. There's much less macros here. There's still a doc block on top, and this is now telling us what is the API for this C function, because those can be equally hard to read. So we see it takes the same parameters as well as a behavior, which is going to be 1 or 0. And that's because this is a common function to array search and inArray. So behavior basically controls whether we're going to return true or false, or whether we want to return the value that we find. And if we kind of walk through this, we see we set up some zvals at the top. We set up a lot of the internal types are just prefixed for portability reasons. So a zen ulong is just a kind of a long integer value. There's a zen string there, a zen boolean value, which is just going to be a true or false. Zen parse parameters, kind of all the functions that interact, like we have to parse the parameters coming from PHP. So there's a set of macros around so that makes it easier, rather than writing a lot of complicated C code over and over again, we have macros to do the job for us. So this is hopefully more readable. We say we're going to start parsing PHP parameters, we're going to declare them, and then when you call this in PHP code, it makes sure that that first argument gets stuffed into the value zval, so that we could work with it later on. And then things like the optional one, there's one macro that says everything after this is going to be optional, and that's going to be the strict flag, which is going to be true or false. And that will also be stored directly into that Boolean value. And then this is the basic flow for inArray, and if it's strict mode. So we have macros for kind of doing a for each iteration. So that array argument, which is going to be the second argument there, we kind of do a for each, and this is internally becomes an actual for loop in C code, but we don't have, there's a lot more things that we need to juggle. And I think, even not being familiar with C, we can kind of read what's going on here. As we go down, we see there's some check there to see if it's identical, and if we actually found something, we return true. And basically at the end of this iteration, if we're searching for something, we'll return false if we don't find it by the end. And then the other mode there is actually returning the index for inArray. So if it was a string index or a numeric offset, we're going to return a copy of the string or the array index afterwards. So this could also be used for, what I've used this for, is figuring out what all these really poorly documented SPL functions are. So things like caching iterator, I wanted to use this in our PHP driver so that we can cache results. This does not do what you think it is. This is a completely rubbish class. Don't bother using this. But LXR was helpful for navigating the source code and finding out, well, how does this actually work? And this could also be used for kind of anything in the documentation, certainly things that say that they are not documented, we just give you the arguments. And then maybe probably should have gone back and contributed some documentation to this. But it's helpful to say there's RFCs. If anyone's familiar with Ben Ramsey, is another conference speaker. A few years ago, he wrote a blog post and gave a conference talk about how he added a new array function to PHP. And kind of following the same process, like he wanted to add a core function for doing some new operation with arrays, and he was able, like, use LXR, kind of look how existing functions are created, get a sense for how they're written, implement his own, submit the RFC, eventually made it in. So LXR is definitely a very useful tool for doing this. Certainly for, and even now that I'm more familiar with PHP source code, I still use it to navigate. It's just much easier than jumping around and doing a grep through all the directories to find things. So take a little bit about executing PHP. So we talked about the life cycle of how a request, how modules get started up, how incoming requests are served for CLI or a worker or threading model. I want to talk about, we have a PHP source code file. We're going to run it through PHP. What is the process? What happens to that source file along the way? And this will play into opcode caching and how we can hook into things. So there's a difference between interpretation, which is what PHP does, and compilation, which is something that Java does. And this is already kind of puts us at a performance disadvantage because we basically take our PHP script, we have to parse it, parse the language syntax, the grammar for it, create some set of instructions, which for PHP we call these opcodes. And there's some analogy to things like assembly. When you compile a C program, we're parsing syntax and making machine language. Down there, the binary file for the Java at the bottom, that's basically the machine language that runs. But with PHP, we never actually create the raw instructions for the machine. That's always being, we're going to create these opcodes, and then those opcodes are always going to be interpreted time and time again. And this is something certainly that HHVM addresses, because it kind of brings us to the model on the right, where it actually does make bytecode for PHP and hackling source. But in the interpretation model, once we have these opcodes, we then feed it into the Zend engine, so aptly named, and that's going to interpret them and actually manage them, like execute the branching logic, create variables, write, do all sorts of things that we expect our script to do when we're running it. But the benefit of Java files, basically, we have this binary file, we compile it once, and then we can run that, and it's going to be much more performant. But there's definitely improvements that we can make to the PHP interpretation here. So this is a very admittedly contrived PHP script. Really doesn't do much. It is PSR2 compliant, so it's got that going for it. Basically, just a basic hello world. I'm not even calling the function in this, so take that in mind. If you run this, absolutely no output is generated. But it's concise enough. I just want to show you what the opcodes that are created for a test. So you're writing this function, and the first thing PHP is going to do is try and parse this into tokens. And there's a userland function called token_get_all that you can use if you want to play around with this. Basically feed it some PHP source, it gives you back a list of tokens that it parses it to. So some notes here, all the PHP language constructs and things like like string literals, these are all represented as tokens. The only things that don't have specific name tokens are the single character things. So braces and parentheses, it would be, someone had the good foresight to say, well, it's going to be really redundant if we create a constant for this. Let's just use the character itself. It's unique. So those remain as is. But things like the function, the string, white space is also a token. I've just hidden it here because it would just make it hard to see the actual important stuff. But this is basically, if we just go between the two, we can kind of see everything is basically there. They're on the same lines. Every line basically gets tokenized. And then the next step is going to be, this is going to get parsed into a syntax tree, which is all the internal stuff that we don't have to with using Bison and Yak internally. If you want to interact with that from userland, Nikita Popov, one of the internal contributors, has a PHP AST project, so PHP 7 has APIs to work with the syntax tree when it's parsing. So instead of just getting tokens, you could actually get nodes where you'd say, well, this is let's say this is an assignment and it has these operands and this destination variable. And so you kind of work with them in a programmatic, kind of like a graph object-oriented way to interact with PHP source. And we could do this to pretty cool things, like you can rewrite PHP source instead of doing it by string manipulation. You could actually just move objects around and do all sorts of optimizations this way. I'm not, if you're curious about that, you can definitely look it up. But what I want to focus on is, now that we have the tokens, we parsed it into syntax, how do we get into the opcodes, or the instructions that are going to get executed? So this brings us to the Vulkan logic dumper. I don't know the history of that name. You'd have to ask Derek Rethins. He's the one that wrote this, along with Xdebug and all these other things. But if you ever use the website, I think it's 3v4l.org, eval in hacker language, you could feed it PHP files. It's an easy, there's a tab, an additional preview your script in different PHP versions. It also gives you a tab to see the raw instructions. So that's an easy way to get this if you don't want to figure out how to install Vulkan logic dumper on your own. But this is a snippet of the output for the test function. So remember that all the function did was it echoed something, returned 0, it had a blank line, and then it echoed something else which would never get executed. And so here the opcodes know what line they originated on. So if you want to play code golf, all your opcodes might be on the same line. If you decide to write PHP without any line breaks, please don't do that. The number is basically the opcode, which obviously starts at 0 and continues forward. The asterisk basically tells us these are opcodes that are never going to be executed. So you might say, why are they here in general? This is a one-to-one representation. We could talk about optimizing that later, but VLD knows that these are serve absolutely no purpose, those last two opcodes. E is basically the entry point of this function, so the first opcode in the function probably is always going to be the first one. And then I and O are related to branch starting and exit. So if we had if conditions or like a for loop, we might see some I's and O's. But hopefully you see the opcode here. PHP, I forget how many opcodes it has, probably a few hundred. I could be pulling that number out of my ass. But there's an echo kind of maps to its own opcode, and if we were using probably a print function, internally printing is still ultimately probably echoing, unless it's a language construct. So echo and print I think are the same. And a return statement, exit and die are probably the same opcode. And what we have here is, so we know those last two ones are dead. We could probably get rid of these. So this brings us to opcode caching and optimization. So with opcode caching, this is hopefully something that we do in production. So I mentioned that PHP's problem is we have to parse, we tokenize, we parse, we build opcodes, and then we interpret those time after time. So what if we can get rid of the parsing and the AST processing step, as long as we're guaranteed our source code doesn't change. And so in production, you might have different caching strategies. On a dev box, every time you load a PHP file, you might want to check if it changed on disk. In production, you're going to do one deployment, and you don't want to keep consulting the file system every request. You just want to use the cache. So you'd have a different caching strategy, but let's assume in a dev environment, we know the file hasn't changed, so the opcodes for it should be the same. So we can go back to our cache and skip all that parsing and tokenizing step. And then the result of that, we're going to save to some shared memory, shared beyond just our PHP process. So I'd really like to use this in the Mongo driver so that each request didn't have to could share connections across itself. But Opcode Cache does this, and it's basically shared memory for your entire deployment. So if you have an FPM with 100 PHP workers, they can all share the same opcode cache on shared memory. And now, when a request comes in, if it's cached, we could immediately just pluck that up and kind of send it still right to the Zend engine. Now, one thing we're not doing here, we're still interpreting it. So it's not as good as what like HHVM does by having a JIT and then allowing the opcodes become optimized bytecode, and then we can just be more like Java in that sense, more performance. Additionally, so the op arrays, basically the sequence of opcodes, still gets interpreted every time at runtime in any PHP application. But the other thing that we can do here, though, is those op arrays can be optimized. So the op array, if we go back to these slides, the op array here basically has 4 elements in it. So we can optimize this. And your application will basically be a ton of op arrays. So OpCode Optimizations, and this is kind of like error reporting where these are all just bit flags. So if you want to enable all your optimizations, go nuts. Set your thing to -1, and basically turns on all the bits. I'll just kind of walk through at a high level what some of them are. So in the first pass, and the passes don't necessarily build on each other. You can they're just uniquely identified basically. But we saw, so down at the bottom 10, that's remove no op. So those last 2 instructions we could just get cut off. We know they're never going to execute. Things like the first one, if there's things with literal arguments, we can make optimizations and kind of embed those and kind of reduce, maybe combine operations that work with the same literal arguments, because we know that if you're concatenating the string foo with bar, rather than actually do the concatenation and have PHP interpret that, we know the result is going to be foo bar as one string, so we can just do replacements like that. The most complex one here is going to be pass 5, and this is your control flow graph. So this is kind of think of a graph or a flow chart of all the paths that the PHP interpreter will take while running your function, your framework, your entire application. Get a sense of like how big and how many different branches you might have in your PHP code. So different chunks of control flow can be optimized. So if we know that there's like loop optimization, so something that's commonly done in C, which I would expect that this probably has a similar feature, is that if we have like a for loop that we run 3 times or 5 times, it might be more performant to just unroll it and just do the body of that loop sequentially 5 times instead of actually jumping back to the top of the loop. So that's one kind of optimization. It's not always the best case, but this is where some logic and analysis comes in, and something that HHVM actually benefits from, because it can, so these optimizations are done without any knowledge of how PHP is running. We're doing this before anything gets interpreted, whereas HHVM has the ability to say, we know what the hot paths, like while we're running our bytecode, we know we can make adjustments to these optimizations. So that's definitely a leg up for HHVM, I'd say right now. And then ultimately, people do want to add a JIT to PHP, and that would probably improve some of these optimizations. But know that these are there. These are also very poorly documented. So I'm going to share the slides. The links in the bottom helped me find this, because the INI settings in the PHP.NET manual don't do anything to explain what these are. It just says, this is an INI value. You can set it to whatever you want. So this actually involved reading the opcache source code to pull these up. And so the last thing I want to talk about is, so that's basically how PHP gets interpreted. How does PHP interface with C and other lineups? So if you've ever experienced a PHP crash, if you're using extensions that integrate with other C libraries, or even just something like OpenSSL, how does that line up? So in an operating system, briefly say there's things called system calls, and think about this as like your Linux kernel, your OS X kernel. They provide a very basic set of essential APIs. And there's things that you might think would be here, like, well, malloc and free, like allocating and freeing memory. Should that be here? That's actually a higher level API. The basic API there is all the way at the bottom, allocate process memory. Basically, is when my process gets loaded into memory, maybe my Apache web server, my PHP CLI process, it gets a segment of memory, and then there's a system call to say, I would like to add some more to the bottom of that, or I want to remove some. And when you're actually allocating, internally, there's more memory being expanded to your process or condensed, but the actual management of, well, this pointer needs to be freed and this thing is all much of a higher level API. Similar to what Zen Memory Manager does for us. Some other basics here are just opening and closing a file descriptor, whether that's an actual file, a block device, like if you're interacting with a USB device, it's going to be something that you can read and write to, or a socket if you're doing any kind of network programming. Reading and writing to those is also going to be system calls, forking and execing. So your entire computer starts as one process, spawns other processes. Certainly, analogy, visualizing this with PHP processes, we fork a bunch of worker processes. And then waiting on them to finish. Exiting and then killing is sending signals to other processes as well. Map and unmap is basically saying that I have a file or a device and I want to access it instead of using reading and writing directly. I'd like to access it into memory. So basically take this file on disk, and we use this in MongoDB for the database. We have these large database files on disk, and I want to access them through RAM and let the operating system handle moving the content from disk into memory and taking care of the caching. So these are your low-level system calls, and even writing a C program, you probably don't have to interact with a lot of these directly, but PHP certainly does when it's compiled. 3 minutes. And so you have the ability to trace, if you want to find out, like, well, is PHP opening sockets? I can trace system calls with the strace utility. So this would kind of give you a sense that if I just have an echo, it's actually using the right system call. This will get more intense if you want to look at what INI files are loaded. You could have the ability to do that. And then ltrace, so system calls are just that basic API. If you want to say, I know I'm interacting with OpenSSL, what functions there do I use? ltrace is a similar tool that can be used for that. And so this is seeing what are the MongoDB C driver, what methods do we interact with there? So I can do a trace with that. And the tracing runs basically as you run your program, it watches and tells you what you end up calling. And the last thing here is debugging crashes. And so most commonly you might experience these as segfaults. And PHP.NET has a guide of how to create these both on Windows and Linux. And if you're working with them, PHP source also includes a set of macros that you can use to like print a Zval and see some nice output instead of getting raw memory. So definitely be aware of that. And so I went to this repository, PHP Crashers. These are PHP scripts that create segfaults. Of course, something like this exists. Decided to use this one that is a recursive two-string. You run this, you get a segfault, no problem. A lot of these things are due to recursion, which PHP can't catch. If we run this, boom, segfault. Same thing if you ran this in Apache. The core file maybe doesn't go to the same directory with Apache, but it does end up somewhere. Your operating system might be configured to put it in a certain directory. So that's usually the hardest part in a production application, finding out if there's a crash, where did that core dump go? And we could also run the offensive script through GDB, which kind of gives us a live view of it. Just give you a sense, so this is recursion, so there's going to be a huge stack trace here. This is the end of it, and I kind of highlighted why you could see these are repeating over and over again, and we're 46,000 frames in, and this is where the operating system, not beyond PHP, the operating system decided I've had enough of this, please stop. And just to show that I'm not lying to you from the initial, the very early slide, it does all start with main at the bottom. And we see the steps here. We do CLI, we're using the CLI SAPI, we're executing a script, and that's probably like loading the script from there. There's more things happening in between, but this is just our stack trace. And then finally executing it, and then we see about 10 frames in is where we actually get to, we're already running the instructions to cast our object as a string. And then the nonsense starts, and we just keep looping over and again. Okay, take a breath. That about sums it up. Happy to answer some questions. These are some resources. Again, I will share these slides. Sarah Goleman, who's a national treasure, does not have a blog anymore. But if you follow her on Twitter or her adventures in RPHP, the subreddit, there's an anecdote. This week, she was getting into a large debate about somebody with justifiable use of eval in PHP. And she was actually like, okay, I can see this is the first time in 20 years that this is maybe a legitimate case for eval in PHP, which I found absolutely fascinating. It was a great read. I was reading it in bed while I should have been working on these slides earlier in the week. So dig that up. Just go look at her Twitter or Reddit account and see some of the stuff. And then some of these other blogs were also very helpful for me researching this. And certainly, like a lot of things Derek creates for you working with PHP, XDebug, VLD, stuff like that. Thank you. Please rate to talk. I'll stand out during the break if you have questions. Try and stump me. I don't have any prizes, but I'd appreciate being put in my place. Thanks a lot. Cheers.